Okay, so in this video we're going to talk about how to describe covalent compounds using our Lewis structures. So the first couple of things you need to understand are the types of electrons that are going to be involved in our compounds. So there's a couple different types. First there's something known as a bonding pair, which is exactly what it sounds like. It's when the electrons are shared between two atoms. So this is a shared pair of electrons. So there are two atoms involved here. On the other hand, there's also something known as a lone pair or a non-bonding pair. So lone pair, non-bonding. And these are electrons that aren't shared and they only belong to one atom. So belong to one atom and they're not involved in a bond. So when we're looking at a compound, you should know that the shared electrons are going to count toward the octet of both of the atoms that they're shared with. So bonding pairs, they count for both atoms when you're considering the octet of that atom. That'll make a little more sense in a moment when we look at an example. Sometimes the bonding pairs are represented by a dash rather than two dots. So you'll see what I mean in a moment, but actually not sometimes, most of the time. Bonds are represented by dashes. And there are a few different types of bonds that we consider when we're looking at compounds. So you might know this already. So first of all, there are single bonds. And these are of course made out of one bonding pair. There are double bonds, which are two bonding pairs. And there are triple bonds, which are three bonding pairs. So we can look at examples of each one of these, which we'll do now. Okay, so for a single bond, let's look at, for our example, Cl2. So you're going to be able to see from Lewis theory why these halogens are forming these diatomic molecules. So we know from the periodic table that chlorine has 7 valence electrons. If you're not sure why, write out the electron configuration and you'll see 7 electrons sitting in its outer shell. So let's draw the Lewis structure for this one. So there's the symbol for chlorine and it's going to have 7. So 1, 2, 3, 4, 5, 6, 7. So we can look at this and see that it's missing 1 electron for the octet. So in order to have 8, it needs to gain 1 more. So we are going to draw the structure for this diatomic chlorine because we know that a chlorine is going to form with another chlorine. That's going to be able to complete our octet. So here's chlorine. Once again, 7 electrons. Here's another chlorine. 1, 2, 3, 4, 5, 6, 7. So between these two chlorines, there's these 2 dots, and these are the bonding electrons. So this is our diatomic molecule. So let's rewrite this using a dash now. This is what I was talking about. So here's our diatomic molecule, and we're going to put the non-bonding electrons around it, represented as dots. So this dash is understood to be two dots, basically. 2 dots are 2 electrons, right? So 2 electrons. So that's an example of a single bond. Now I'm going to draw an example of a double bond. So for the double bond, let's look at oxygen, so O2. So we saw from the last example, oxygen has 6 valence electrons. So let's draw that. So here's oxygen, 1, 2, 3, 4, 5, 6. So it's missing 2 electrons to complete the octet. So that means when it forms a diatomic with the other oxygen, it's going to share 2 pairs of electrons. So let's draw that as well. So here is oxygen, 1, 2, 3, 4, 5, 6. And then here's another oxygen, 1, 2, 3, 4, 5, 6. So the correct way to draw this would really be like this. So it's going to have these 2 bonds in between and the 8 or 4 electrons on each oxygen. So it's going to be sharing 2 pairs, and we're going to represent the double bond by these 2 lines. So this is a double bond right here. And now each oxygen has 8 electrons in its valence shell, just as it should. And then finally we have a triple bond. And I'll leave it as an exercise to you to draw this Lewis structure. So I'll give you, for example, N2. So this is a molecule that has a triple bond, and so yeah, you draw the Lewis structure on your own.